Physics versus like environmental science. It's because I feel like everyone really wondering. Yeah, it's okay. People like it. That's how they're doing it. It's just like I can't.
Okay. Yesterday, a lot of people were asking about and hyperventilating about, oh my God, how accurately do we need to graph these slope fields? And my answer is always, we never ask those because they're such a pain to grade. We put one on last year. So this is what it was last year, and just want to show you. And this took twice as many days to grade as any other question. We have 5 to 7 days to grade AP, like all 50,000 just one version. This took 10 days. They were emailing everybody, please come grade. Like, oh, I have other things to do. So this just asked for, with that slope field, sketch the solution curve through this coordinate. So that would be not so great. And I don't know that we should put arrows on it. The grading rubric that they say, things that needed to happen. The solution curve needs to go through the coordinate requested, and it needs to extend reasonably close to the beginning and the end, like meaning it's gotta cover the whole box they gave you. So draw the whole thing in the space given. Only portions of the curve within the slope field are considered. The solution must stay below, in this particular case, that horizontal line. That horizontal line represents an asymptote, and they didn't want you to cross it. And the thing I drew the first time made it touch the line, and I was like, that might be bad. That's part of why this was a pain to grade, because like, well, is it that much of a violation? All that for just one point. But those are the restrictions for this particular one. Make it cover the whole space they gave you and hit the conditions that are part of the graph. So make it go through that coordinate and make it stay below the horizontal asymptote. Did you guys have questions? And someone asked, part B, yeah, Taylor series text, chapter 9, we're not there yet. No, you can't do that. Other questions from the worksheet yesterday?
Are you just looking at the graph for question 4 and then part D for the range? Or like using the equations?
All right.
Like if you weren't given the graph, what would you do?
So
The particular solution as an
So the slope field looks kind of like that? All right. Aton? Question?
I had a question about like for
Yeah. That's what Sophie's asking as well. All right. So quickly, part B. Explain why the solution couldn't be this. What's our reason? So anything like the function has a slope of 0 or a horizontal line at whenever y is 0. This isn't equal. So something to that effect. Okay. To answer part D, we need to do part C. Find the particular solution. They are asking us to integrate this. dy dx equals x times y minus 1 squared. Massimo, how do I integrate this side?
You substitution, or, that's what I did.
Can I do it just power rule?
Yeah.
Raise the power to y minus 1
Yeah, and then, divide by negative.
and then divide by -1. Okay, so, and then technically divide by the derivative of this stuff inside, which is a 1, so that's good. This is x squared over 2 plus c. I like to plug the coordinate in sooner rather than later. So right here, I'm gonna plug in 0, -1. So, um,
0, -1.
it's in the problem, it's hard to see because it's almost off the board. So -1 over -1 minus 1 is -2, so that becomes positive 1/2, is that right?
1/2 is equal to C.
1/2 is equal to C, all right. So my function becomes -1 over y minus 1 equals x squared over 2 plus 1 over 2. Can I do that? Because now, if I didn't do that, then the next step is harder. I'm gonna multiply both sides by -1. Just change the signs on both sides. And now I'm gonna turn everybody upside down. So I get y minus 1 equals -2 over x squared plus 1. And now, part C was the hard part. Part D is pre-calc. Hard pre-calc, but it's pre-calc. What is the range of this answer? What do you think?
Well, there's like a horizontal asymptote, I think,
Where's the horizontal asymptote?
at 1.
Does it hit 1?
No.
Yeah. So that's like the
No.
top,
Why do you know it's the top?
because it's a negative.
Okay, so, alright, let's go pre-cal on this thing. So Cecilia is saying, basically, as x goes to infinity, because she says it's an asymptote, horizontal asymptote, so we super duper that way. This denominator gets huge. -2 divided by huge is basically 0. Is it actually 0? No. So basically 0. It's really, really close. So this is almost 0, so we almost get to positive 1. So there's going to be a round bracket on that 1. Is it going to be any different if I go to negative infinity?
No.
No, it's still going to be a 1. Okay, so where's the other end? What's going to make this?
Simply make x of less value to make the fraction larger.
Okay, so what is the smallest x?
0.
0. Yes. So when x is 0, this is -2 over 1 plus 1, which is -1. Does it hit -1?
It does.
It does. Round bracket, square bracket.
Do you do x is 0 because that's the initial condition?
No. You gotta think of it, so Amir was like, you wanna make that denominator as small as possible.
Oh, I see.
So, like, strategy-wise, like, I don't have a good reason, but when is the denominator as small as possible? We said when x is 0. Okay. Other questions from the worksheet? Yeah? No? Yes? Yes?
For part C on 5, I solved it, but I think I like dropped a negative somewhere, but
I was solving the integral of 1/6 minus y. And I divided by like the derivative of the stuff inside, so I divided by -1, but
Of course, I have all the answer key up. I don't have that one.
sorry.
All right.
I can just resolve it, it's okay.
Okay, well, this is good review for, test. So consider this differential equation and let the particular solution. So, how do I separate the variables?
Take
Back your mouth.
Hadley says take out x squared. If you guys are trying to isolate the variables by adding or subtracting something, you're not on the right path. And Sakalia, right now, I think I see where your issue might have been. So now integrating here, this is natural log of the absolute value of this, divide by the derivative of the stuff inside, which is a -1. And again, I prefer to plug in the initial value early. I'm gonna make that a positive and this a negative. And now I'm gonna plug in the coordinate -1, 2. So Camden, what do I get when I plug in that coordinate?
I guess 1/3 plus C on the right, and then get L and 4.
So 6 minus 2 is 4, absolute value is just that positive, and you said over here, -1 cubed is -1, but there is a negative on it, so it's positive 1/3, okay. So gross, that's my C value, okay. So natural log of absolute value 6 minus y equals, wow. -x cubed over 3 plus Clara had said we wanted it in the form of y equals, and y is all trapped inside there. What do I do?
You can put both sides to e.
Exponentiate. What comes out is absolute value of, okay, I'm gonna, e to the natural log of 4 is 4. Is that okay? I don't have y out of here yet. So either, to get these absolute value bars, either this is positive or this is negative. Which way does it go? So solving for y, do we want this? Or do we want this one? Which one gives me the y value that I want?
The bottom.
I want the y value to be 2 in the end. So when x is -1, the exponent on e is 0. So the one on the bottom gives me 6 plus 4, which is 10. The one up top gives me 6 minus 4, which is the 2. So I want that one.
How did ln become positive?
Right here, I multiplied by a negative on both sides before I plugged in my initial condition. Okay? So the test next week is Thursday. Yay. Still hoping for a super happy snow day on Tuesday, but you know, the weather is like looking warm and thought it gonna happen. All right, any other questions on this worksheet from?
How did you figure out if the epsilon value was positive or negative?
Okay, so Amir, if we look at this initial condition,
Yeah.
when I put in -1 to the E stuff, it's really hard to read my handwriting because it's just not doing well today. But that exponent's going to be 0, right? So e to the 0 is 1. So I'm just going to get rid of that stuff because it's just in my way. Which one equals 2? 6 minus 4 or 6 plus 4?
-4.
So this is the one I want because I wanted the y value to be 2.
Okay.
Okay. The sheet that I asked you guys to pick up on the way in is an engineering problem from the Naval Academy. Beware when you sit next to me at Thanksgiving. I'm like, oh, you do what? Huh? Cool, let's chat. Raphael didn't know what hit him. Okay. So this is a real problem, and it uses Newton's law of cooling. It uses Eulers method. It uses slope fields. We can just read through the problem at first, but I want you guys to fight through it. It's reminding you of some pre-cal. Okay. So you're the engineering officer of the watch on board the USS DG-91. On your first watch, one of the LM 2500 gas turbine engines overheats and you have to shut it down. When you stop the engine, its temperature was a mere 1600 degrees Fahrenheit. The engine room's ambient temperature is 85 degrees Fahrenheit. We know that this engine cools at a rate of 20.2 degrees Fahrenheit per minute. And it depends on the temperature of the thing itself at the time. It cools differently as it cools. So using Newton's law of cooling, this is the differential equation. Find K. So that's pre-cal. Can we answer B? What is the initial condition?
The FDT is
Okay.
yeah.
So the temperature
8.2.
to start is what again? 1600. Okay. So can you guys go through and see if you can use your pre-cal from the past to find K?
So we'll find
And try the rest of the problem. See if we can figure it out.
20.2.
I mean, it looks like it's not. But I feel like there's a way to show that.
So from pre-cal, this is one form of how Newton's law of cooling can be written. T to the N, all the combination of things, temperature of the environment. You guys get it? What did you, Cindy, what did you guys get as K?
Yeah, I divided by
Oh, I see why.
Anyone agree with this?
Yeah.
That's the same answer.
This is making sense, 'cause now M is 85. You gotta start with
Oh, because it's degrees.
Oh.
We just use logic and not the answer.
Yeah.
Which is good. You understand. Like how to prove that, yeah. Oh, I think we plug it up first, and then all codes, yeah.
Question? No?
So now the small recipe is like do this 85. We plug in casualty is 85. But then when should we use a calculator like
Oh, yeah. It doesn't really fit.
It's okay.
And it didn't really fit on my paper either, so I kind of only did two.
All right, guys, question. Does slope always have to have, when we found our new dy dx, when we did the Eulers method, did we always have an x value? Did we always have a y value? Did we have to have both? This one, someone noticed, I don't plug time in anywhere. What the heck, man? Is that okay? I mean, the equation is just based on temperature. So, all right.
I don't know the second. I didn't write down the second decimal point.
Oh, that's okay. So I didn't give you enough space to keep 3 decimals, so we'll let it slide. That we started at 1600. I'll let go a few decimal places.
I think it's just consensus.
in my fraction session, you know, just they round it. Like we round it to 7 yards. Oh, they updated it. I know. Yeah, mine's the much.
And then we have the writer.
Hopefully we're on like the same. We probably are. It's fine. I'm gonna set it Given temperatures in 2 hours.
Okay, so in about 5 hours by this calculation, it seems like maybe it's around 300 and something degrees. Okay.
And taken a number of training courses and things at the Naval Academy, and they referred to some things as the nuclear bomb method of things, which they meant to say, well, just as a quick answer, what's up? So sketch the solution curve. What was okay, so starting at a temperature of 1600, sketching the solution curve, that's there, like really fast. What's it look like? The temperature is going to be in about 2 hours. 2 hours is 120. So The way I graphed it here, it actually looks 300-ish. That's the quick estimate, but you can be really, really far off with your slope field. Doing Euler's method gives you a much more accurate thing, and actual integration, of course, would be the best. What is this thing? What's the limiting temperature over time? What is it?
85.
85. Why is it 85? Temperature of the room.
I got a question wrong because I don't know if it was the max
So the limiting factor is the temperature of the room, the medium. It's something immersed in water. Temperature of water.
It would have been so good. It's killing me. I feel like my eyes are if I multiply plus C by -1, is it still?
Did you plug in your initial condition yet?
I can do that and then.
Because if you didn't plug in the initial condition, it doesn't matter what you do.
Okay, that's what I see had is 69. Okay, perfect.
Did anyone get the particular solution?
I got it.
You wanna write it up?
It's 305.263.
You have to divide by
Calculated it.
ln. Oh wait, no, you don't.
Yeah, so for the Euler's method, 305 and something.
Yes.
Because I divided by -1.
Calculated it.
Because I figured like it's ln.
Did anyone get the equation though of temperature? ATOM? You wanna write it up?
Oh, I guess I can't plug in anything. But I know, 'cause it's not hard.
Do I just write it or do I have to like
You
show
can
it?
write it.
I'm stuck. I missed it.
Oh, yeah.
But yeah, how do you plug in? Like, there's two. I guess.
Yeah.
Alex, did you figure out how long it takes for the temperature of the room to exit? So, yeah.
That's it. Then you don't even have a.
No?
You know?
Yes, no, what? What's the answer?
Oh, I just took it.
What is it?
346 minutes.
346 minutes, so that's 5 hours and 46 minutes.
This answer was
No, because I never divide. I
You
always
get that
multiply. Because
solution
now
from
it's
fucking pull it out of your ass.
What? Oh my god, I did the same thing.
I always do
Right,
this.
it's
Okay,
so much.
anytime, how did you get to this? People are. Or Jasper, what did you guys do? Because they got this answer too. What did you guys do? I have
No idea.
Okay. Well, to get the answer, we need to separate the variables and integrate, right?
Yeah.
So T with T and little t with little t. It is unfortunate that temperature and time, oh well.
What is that?
Do we just not ever plug in?
So yeah, K is a constant, sort of. For the problem we'll say it's a constant, but as temperature changes, that K constant does start to change.
So this is like part of the integration.
Well, no, still using it, like, our answer's gonna be off because it cools differently when it's 1600 degrees versus when it's seasonal. Like, if you have boiling water out on the ice, it's gonna cool faster.
I still have to write it out.